Shetland is the most northerly part of Scotland, 200 miles north of Aberdeen in the centre of the North Sea and Atlantic oil fields. The islands cover an area of 500 square miles, but the population is only 24,000. Lerwick is the main town with a population of around 8,000 and is the administrative, commercial and industrial centre of the islands. Traditionally, Shetland Islanders were frugal, self-sufficient people, throwing away nothing that could possibly be reused, repaired or burned to provide heat for their homes. But, as in the rest of Scotland, the more wasteful ways of modern society have slowly taken hold, and the amount of waste being produced is increasing every year. Shetland had been operating an oil-fired waste incinerator since the 1970s, but it was expensive to run, and by 1993 it could not meet the latest emission regulations, so the local council started looking at new strategies. With historic connections to Scandinavia, it is perhaps not surprising that they looked in that direction for ideas, and council officials visited Denmark, where district heating systems are common. In Bornholm, a Danish island in the Baltic, there is an energy from waste plant linked to a district heating system, and this seemed an ideal model for Shetland. In 1997, after much discussion and public consultation, the decision was taken to construct a similar system in Lerwick, and 2 years later, the energy from waste plant was opened on an industrial estate just outside the town. Visually, it does not stand out. It is simply another industrial facility. The industrial estate is served by an A-class road, and traffic to and from the plant is insignificant alongside the other industrial traffic. Just across the road, a new landfill site and materials recovery facility are being constructed. The proximity of these facilities to one another minimises transport distances, reducing costs and pollution. The whole complex is set into the hillside and only clearly visible from the top of the hill or from one remote croft on the neighbouring island of Bressay. The plant is part of an integrated waste treatment strategy. Curbside collections of recyclables, along with recycling points and centres throughout the area, reduce the volume of mixed domestic waste. The residual waste, along with residual domestic waste from Orkney and waste from the offshore oil industry and other local industries, is disposed of in the energy from waste plant. Most of the industrial and commercial waste goes through a materials recovery facility, and at this stage large plastic items such as salmon feed bags, which have too high a calorific value, are removed. The waste is tipped directly into a reinforced concrete bunker, and an overhead crane thoroughly mixes it to ensure a more consistent calorific value, enhancing the operation and performance of the plant. The crane grab then loads the rubbish into a hopper which feeds the furnace. Hydraulic rams push the waste onto a 3-section sloping grate, which moves down at a rate controlled by the furnace operator to ensure complete combustion. The furnace runs at a temperature of approximately 1200 degrees centigrade and is fitted with oil-fired burners which cut in automatically to boost the temperature should it start to drop due to low calorific value waste. Once the waste has been burned, the bottom ash, along with any metal objects from the waste, falls into a water quench which cools and prevents dust. A rotary magnet separates out the ferrous metals for recycling, and the bottom ash, which is inert and harmless, is sold for use as primary landfill cover. Fly ash and gases from the furnace are then passed into a post-combustion chamber. Here, an induced cyclone removes the larger particulate material, and dioxins and other hazardous gases are destroyed by ensuring a temperature in excess of 850 degrees centigrade for at least 2 seconds. The gases are then passed through a 3-pass boiler, which heats the district heating water to a temperature of 115 degrees centigrade. The gases, now at a temperature of 180 degrees centigrade, pass into an electrostatic precipitator operating at 60,000 volts, which ionizes and removes fine particulate matter. Next, the gases pass into a wet scrubber, a specialized apparatus that uses a system of water and alkali sprays to absorb and neutralize acid gases. Finally, in the baghouse filter, a mixture of powdered lime and carbon is used to remove the last traces of acid gases, mercury, and other pollutants, along with any dioxins which may have regenerated during the cooling process. The cleaned flue gases are then released to the atmosphere at a temperature of around 100 degrees centigrade through a 46-meter chimney stack. Emissions are continuously monitored to meet the Waste Incineration Directive. The highly acidic effluent from the quench passes through a water treatment plant, where it is neutralized with lime milk and chemicals are added which cause heavy metals to precipitate out. Finally, we are left with clean salty water, which is discharged into the sea, and a thick, damp sludge, which must be sent away for treatment. Deposits from the post-combustion chamber, electrostatic precipitator, bag filter, and water treatment are classified as special waste and are shipped to the mainland for processing. Each year, the plant processes around 22,000 tons of waste. Approximately 300 tons of metal are recovered for recycling. Around 5,000 tons of bottom ash is produced, and this is used for primary landfill cover. Just over 100 tons of filter cake from the water treatment plant and 420 tons of fly ash from the bag filter and the electrostatic precipitator, that's less than 2.5% of the original waste, is sent for chemical treatment. The plant is designed to operate for 7,800 hours per year, on a 24-hour-a-day, 7-day-a-week basis, and on average, the plant produces 6.5 megawatts of power, enough to heat 3,500 to 4,000 average British homes. The water, at a temperature of 115 degrees centigrade, is pumped approximately 2 kilometers to the district heating peak load boiler station. Here, the temperature is reduced to 95 degrees centigrade by mixing in some of the returning water from the heating network. It is then pumped around the 27 kilometers of pipes in the system, returning to the pump house at a temperature of 55 degrees centigrade. The Lerwick district heating system, operated by Shetland Heat and Power Limited, now serves around 800 houses and 100 businesses and non-domestic properties, including a local leisure centre, schools, churches, and a wide variety of commercial enterprises. In fact, the scheme has become so popular that there is now a 2-year waiting list for connection to the network. Premises served by the system have their central heating boilers replaced by a simple heat exchanger. The size of the heat exchanger is tailored to the requirements of the particular premises. In the case of a domestic system, it is similar in size to the boiler it replaces. For larger consumers, however, there is a significant reduction in the amount of equipment required compared with a traditional heating system. Here we see the boiler room which was needed by a local leisure centre when these oil-fired boilers were used. Now, all this equipment has been made redundant by these 2 small heat exchangers. Clearly, there is a significant amount of work in retrofitting a system of this type, and it is simpler and much more economic to connect up new buildings. It is not generally economic to connect up individual houses unless they are within 20 metres of the main pipes. For larger premises and housing developments, however, it is possible to extend the network. In this new housing scheme being built in 2006, the district heating system pipes are being laid along with all the other mains services. At the peak load boiler station, there are 2 standby boilers, which are used when the energy from waste plant is shut down for maintenance or any other reason. These boilers are also used when severe weather causes the heating demand to exceed the output of the energy from waste plant. Plans are, however, in hand to construct a 19-metre high, 300 tons capacity hot water storage tank. This water will be heated at off-peak times and used at times of peak demand, thus reducing the need for the oil-fired backup boilers. The success of the system is such that demand is beginning to exceed supply, so there are plans to purchase waste heat from the power station next door to the boiler station and to commission a special boiler to burn waste oil. So, to summarise, the energy from waste plant blends into its background, an industrial estate. It is adjacent to the new materials recovery facility and landfill site, forming part of an integrated system of waste management facilities. It is close to its customers in Lerwick, and it is on an A-class road. Complex multi-stage treatment of the emissions means that they easily meet the Waste Incineration Directive standards enforced by SEPA, and there have been no pollution issues. Not only that, but if we consider the reduction of the use in oil-fired boilers and electrical central heating in Lerwick, this plant results in the following annual reductions in local emissions. Carbon dioxide emissions down by 7,800 tonnes. Sulfur dioxide emissions down by 500 tonnes. Nitrogen oxides emissions down by 1,000 tonnes. Landfill is reduced by 22,000 tonnes each year. Fossil fuel imports are reduced by 2,600 tonnes. And the benefit to the local economy has been calculated at £1.5 million per year. So, what may have originally seemed like an expensive investment now appears to be paying dividends in many different ways. In conclusion, we would just like to thank Shetland Islands Council and Shetland Heat, Energy and Power for their cooperation and assistance in the production of this video.